Hey everybody, my name is Ryan Steele, and I'm here to discuss with you my main points that I found for chapters 1 through 6. So let's get straight into it. Chapter 1, the Building Green Basics, talks about building and putting an emphasis on the environment as a whole, and how building green can make a difference on the environment and can also conserve natural resources and be energy efficient with the materials we use to build with. For example, the straw bale construction is outdated. It's been used for more than 400 years in America, and straw bale houses are especially sensitive to movement uh, from under or within the structure and may suffer from structural movement, which can crack the plaster and cause eventual collapse and load bearing walls. Moving on to chapter 2, the house as a system focuses on the controlling the movement of heat, air, and moisture in the house and where the energy comes from. Uh, a house is a system with interrelated parts, and energy loses some of its potential each time it's converted. So, say you're on a job site and you hook your circular saw to a electrical outlet, and the outlet has a splitter, and other people on the job site are using the same outlet. Since the electricity is going a few different ways, you aren't getting 100% power to your saw because the energy is being split up. And if you look into how energy is lost in transit, it's ridiculous. And but passive solar energy actually just uses radiant heat from the sun to heat a house, and the energy makes just one simple conversion, and that's from light to heat. The efficiency of passive solar is much greater, and the minimum amount of energy is 50%, whereas a house with well-designed glass can even get up to 75%. And moving on to chapter 3 is planning and design, and it's, if not one of the most important steps to making a sustainable greenhouse, or green house green, sustainable house green. The location of house makes a big deal for the fact that energy can either be saved or lost, whether the location of the house is facing south or not. South-facing houses offer advantages on the outside and on the inside. A house that combines solar orientation with a number of south-facing windows can reduce heating costs substantially. I myself live in a south-facing house, and we have large windows on our back patio, and we've had to put tent on the windows because the sunlight was heating the house up way too much during the summer, and was raising our bill from using AC on full blast. And but while using south facing windows might be great during the winter, it can be very troublesome in the summer. And if you don't mind having to pay for darker tinted windows, then it shouldn't really be a problem for you. Moving on to chapter 4, talking about the foundation. A well-planned foundation can make up a huge contribution to controlling heating and cooling costs, while at the same time eliminating potential problems such as moisture and mold. Foundations are a structural necessity, and you can't build a house without them. Um, they definitely contribute to the overall energy efficiency and air quality tremendously to a house. And perimeter chains are a very important addition to add when insulating the foundation because it helps control moisture. Um, and uninsulated foundations can account for sizable energy losses, and more so in cold weather parts of the country. Uh, Switching over to concrete, the production of concrete actually produces 8% of global warming carbon dioxide, which is, to me, it's just mind blowing. And to fix that would be reducing the amount of huge outpouring of greenhouse gases from concrete is to combine fly ash with concrete. Fly ash is a difficult byproduct to dispose of because it comes from coal-fired energy plants, and it essentially recycles the waste of fly ash by adding it to concrete, and combining both helps the environment a ton. Switching over to Chapter 5, talking about framing. Uh, when I was looking at the framing, the alternatives that really like intrigued me the most were rammed earth and adobe framing. Adobe construction is still used in the southwest of the United States, like West Texas, New Mexico, Arizona, Utah, and even Mexico. The downside, of course, of using Adobe is that you can only build it in dry areas and places that rarely receive rainfall because the rain can easily wash away the mud and ruin the material. Autoclaved aerated concrete, which is manufactured with entrained air to boost R values. It has a number of green benefits, and although wood is still a predominant material for creating like the shell of the house, but a number of builders have abandoned wood in favor of newer materials. AAC is made up of aluminum powder added to the mix of sand, lime, water, and cement, and it traps insulating air bubbles and is an extra insulation that standard 2x4 construction just doesn't have. Switching over to our last topic, or our last chapter, chapter 6, about the roof and attic. The roof is also a great place to set up solar panels to be energy efficient and also to collect runoff rainwater. Some roofs actually have live vegetation on it, and it's very, very interesting to me that the roof's called green roofs, and they've been around ever since the 1960s and are known to last from 30 to 50 years. It can keep a house cooler during the summer and warmer during the winter. The intersections between interior partition walls and ceiling hold a lot of potential for air leaks. In the book, it talks about sealed drywall being used as an air barrier, but today it looks like sealed drywall is obsolete, and drywall is not vapor intelligent, and it isn't flexible. I searched up a better alternative, and I found that Intello Plus, I think that's how you say it, which is an airtight vapor variable membrane that works well with a wide range of insulation materials that drywall just doesn't. And yeah, that's gonna do it for me, guys. I can't wait to see everybody else's videos, and hope y'all have a great day, and stay safe.